We have the opening of the auditory tube, which is this one right here. Then we have the pharyngeal tonsils, which is this one here, which I told you is really not a midline structure. They're bilateral. They're lateral structures, okay? And then the palate is the hard palate, which is the palatine bone and the palatine process of the maxilla. And then the soft part right here, where you see the muscle and then you see the punching bag, the back of your throat, that's the uvula. Okay, and did we talk about that?
Yes.
I mean, what's the purpose of the uvula?
To like.
Okay, so we did.
The nasal
Okay.
area.
Yeah. So whenever you drink the milk, you don't shoot it through your nose, okay? Unless you make your little nephew laugh before he gets a chance, and then it comes out his nose, and you start laughing. Okay. And then palatine tonsils, which are back in here. And all this amber colored stuff is supposed to be a tonsil, and then we have the lingual tonsil right there at the back of the tongue. Okay, and then the laryngopharynx houses the larynx, so that's this area here. Okay, and then we got big models to show the cartilages. Okay, this guy's, you know what? I didn't realize that this guy had some salivary glands in there. Anyway, we pull this off and we look down there and we could see the opening here. This is the epiglottis, okay? So when we're looking at these big cartilages, it's this here and then all this stuff here. So the first one we said was the epiglottis. It's this one here. You open it up. You can see it right there. Okay, and then when you get this big guy here, you can see him right here. Cool. And then we said when you swallow, your throat actually comes up and shuts this thing down so it can shunt the food down to the esophagus, which is directly behind. The thyroid cartilage. Thyroid means shield. Okay, so when you look at these, it's pretty easy to see that this is the shield. Okay, so that's the shield cartilage. The cricoid cartilage is this one here. Okay, cricoid means ring-shaped, like one of those wedding bands that guys always lose. Okay, so those things right there that go around your finger there. All right, then we went to the back. We really can't see it in this one. It's covered with epithelium. Oh, well, no, it's not. It's right here. This is the arachnoid, but the arachnoid means ladle shape. So when you look at this one here, you can really see that there's a ladle shape. And you guys know what a ladle is, right? Mm-hmm. What you get your lentejas with, all right? You pull them in the... Lentils are good for you, by the way. You should eat lentils. I should eat more. Okay, and then we have the corniculate. Corniculate means shaped like a horn, so there it is like this. And when you look at this one, you can see that someone drew a line around that, so you can tell that from the arachnoid. And then we talk about the cuneiforms. They're over here somewhere. I haven't found them yet on a model that I want to tag. They covered by epithelium on this one. Cuneiform means wedge shape. Okay, so we got some cuneiform bones in your tarsals. Okay, so it's somewhere in here. It's like that one there. But I don't feel comfortable tagging it. Okay, so I mean it's this one right here. So it's on the side wall, so we can't see it. So I'm not going to tag it. Although, Vanessa, if you want me to, I'll tag it for
No,
you.
thank you.
Okay, then we talked about the membranes. And we looked down in there and we said, okay, we can see the buccal ligaments. And then when we bring it out like this, we can see one fold here, and then we go in, and then we come back out, and there's another fold here. Okay, so this first fold is your false. This is the ventricular fold. It's the false vocal cords. It's not really, doesn't have any ligaments at all. And then if you look on this one, it has a white line on it. Okay, so that is your true vocal cords, and that white line is the vocal ligaments, which is this right here. And then we said when you move them around, you can talk high, you can talk low, you can talk in between. Are you cool? All right. What happened to the halo? Did you decide to go to the dark side?
I'm just hiding.
All right, then we looked at the trachea. And the trachea has some stuff. Okay, first it's made of hyaline cartilage. And it goes all the way down, so your heart is right there, so it's behind the heart. And then we get to this area right here, and this particular sexy underwear right here is called the carina. Okay, carina actually means heel of a boat. Okay, so when I change the names of these things, I'm calling it sexy underwear. Cool. All right, then we have to go to the histology. So the histology is over here, and here we can see the ciliated pseudostratified columnar epithelium. We can see the mucosal glands, and then we can see the hyaline cartilage on the bottom. Okay, so all that is on the slide presentation over there. We have two primary bronchi. And remember, each division, each time it branches, it becomes a secondary or tertiary bronchial or respiratory. Okay, so we have this one and this one is the primary, which, as you can see, this one is more vertical and shorter and wider than the left, so it usually is the one that causes the problems whenever you swallow something. Like, didn't you say it went into the left instead of the right, which is kind of weird? What was it they swallowed?
It was nuts. It's not like the almond.
Oh, okay, so almond's small enough. Usually they end up pulling out dimes and pennies. Okay, and they color-coded this one so it's easier to see. Okay, so there's the branch, and then there's the tertiary branches coming off. Okay, so that makes that easy to see. And you can see there's 3, and then there's 2 on this side, which is the normal arrangement. So 3 lobes, 2 lobes. Then we start talking about the histology, and we'll have to say that when we get to the histology part. But that's what we're going to look for, okay? So it's outlined over there, all that stuff that you want to see. So let's look at the gross anatomy. Ew, that's gross. Okay, so the lungs actually go from the cupula, right in here, all the way down to about, T10? And then when you breathe, they go all the way down. Okay, so that's how that works. We take this off. Take the other one off, sorry. Take the heart out. And you can see where all these tubes go in, where all this stuff goes in, that is called the hilus area of the lung. Okay, so name this opening, or this transfer of artery, vein, and bronchial. The base of the lung is actually the bottom, and the apex is the top. Okay, now, I did explain base and apex, right? Apex just means the point. So if we're talking about a pyramid, the top of the pyramid is the apex. The bottom is the point. It doesn't matter if it's turned sideways or upside down. If you're the pointed side, you're still the apex, okay? Costal surface is the surface that adheres to the ribs, okay? Because this is up in here. We have the serosa that comes around here, and we have a little bit of water in between. As you expand the ribs, it pulls the ribs. The water pulls on the visceral peritoneum covering there, and so you can see where the ribs are on the lung. And then the cardiac notch is that area for the heart. Well, I'll do it this way. That is the cardiac notch. Okay, and if you stick a heart in there, then you can see how that works. Cool? All right, I still didn't fix that. I just tell myself I'm going to fix that every semester. Okay, so we can see that we have 3 lobes and 2 lobes, okay? This is a oblique fissure, not a horizontal fissure. I think, you know, or maybe it is the horizontal fissure. This has a horizontal and an oblique, okay? It was pretty obvious, okay, to discern which one is which, okay? So we have superior lobe and an inferior lobe, obviously. Then we have superior, middle, and inferior lobe. And when you're doing your auscultation, you want to hear all 3 lobes, so you keep that in mind. We talked about pleural membranes, but we don't have anything tagged, so it's something important to know. But that's how we breathe. Okay, so now we have the muscles of inspiration, muscles of expiration. And where's, did they steal Mr. Purple Guy? Hold on. There's no breastplate on Red Guy, is there? All right, here's Mr. Purple Guy. Okay, so what's the rule for inspiration, expiration as far as muscles are concerned? What is it?
The external intercostals.
Well, basically, it's where they originate, where they insert.
Oh.
Okay, so if your muscle of inspiration, are you going to insert
External.
above or below the? I mean, are you going to lift the ribs up,
Mm-hmm.
or are you going to pull the ribs down?
Up.
Okay, so you must be originating somewhere above. Okay, so we have the diaphragm. Obviously, this is the only one that doesn't follow the rule because it does go down. But what's the rule of breathing? We want to expand the volume of the rib cage and decrease the pressure because we want the pressure gradient to suck the air in. Okay, so there's the diaphragm, and then we have the external intercostal is 159 on this model. Remember, it's going down like this, like you put your hands in your pockets. Okay, so that means if it's a muscle of inspiration, it must originate from the rib above to the rib below. Cool? Then we have accessories. We have the sternocleidomastoid because it attaches to the sternum and the clavicle. Well, since it's attached to the sternum, it's going to help raise that up. Now remember, your head has to be stabilized before it's going to help with inspiration. Okay, and the scalenes here are also, scalenes are in here. They also do that. And actually, the pec minor does that too. But since it's not on the list, I won't tag it. But I expect you to know it in case I tag it accidentally. Okay, so there's the internal intercostal right here, labeled 160 on this model. Okay, and you'll notice that it's got the opposite, so it's doing like this. So it actually originates from the rib below and pulls down. Then we have the rectus abdominis, we have the external oblique, the internal obliquus, and the transversus abdominis. Groovy?
Mm-hmm.
All right. And that's really all the anatomy that we have for the lungs. Okay, so let's look at the histology. right, so on that first microscope over there, this is what we're going to see, and we're pretty much following this. Okay, so we have ciliated columnar. This is pseudostratified columnar epithelium, not really just columnar epithelium. Okay, but it's ciliated. Okay, then we have these seromucosal glands because we need to have the mucus producing glands as well as the cilia to beat that pollen and all that smog that we breathe in back up. And then here's the hyaline cartilage that gives you the rigidity. Okay, so that's what the trachea is made of, hyaline cartilage. There's our bronchiole. We can see the smooth muscle over there, and we can still see pseudostratified columnar epithelium, and it is on this slide right here. Okay, so the pointer is on the pseudostratified columnar epithelium. You can see the cilia. It is beautiful. It is, man, that's beautiful. And then as you go on in, you can see the smooth muscle. Okay, so what are you looking for smooth muscle? What are you looking for in smooth muscle? How do you recognize smooth muscle when you look at a slide? You look at their nuclei. Okay, the nuclei does like this. It looks like a school of fish. Okay, so in that slide, we have the cilia coming like this, and then you have the cells themselves, and then out here you can see these little school of fishes sort of swimming around this area here. Of course, this is the lumen. Cool. So that's how you can tell smooth muscle from anything else. Okay, so this is smooth muscle. See all these little fishes coming there? This is little fishies coming in there. Okay. Did you ever put your little pole in there and pull them out, those little fishies? Okay, and then as we moved on, we look for the terminal bronchiole right here, and we have its own slide. Remember, it's this big vacuous slide, though. It's not as pretty as this one. This is, man, if I could find a section like this, I would, well, I wouldn't give up one of my dogs. No way. I'd give up Wasita. Okay, so over on this third slide over here, I want you to look at the cuboidal epithelium. So the pointer is sort of like in the middle there, but I want you to look on either side of the pointer because it's just in the airspace. And I want you to notice. Now, how do you know it's cuboidal epithelium? What's the dead giveaway that it's got round nuclei, because what do you put in a cube? You can't put something oblong or flat in a cube, right? Mm-hmm. So if you're cube shaped, your nuclei is going to be round. And then as you move on down, okay, then we can see the respiratory bronchiole, which is simple squamous. You can start seeing the alveolus come off of it. If it looks like a little hallway, how do I get rid of that? What? What in the world? Get out of that. You're supposed to be on my notes. Is this it? I'm beginning to believe in aliens. Okay, so there is the hallway, the alveolar duct. Okay, and remember it's long. Then when you get to a terminal area here, this becomes the sac, and then all these become the alveolus. Does that make sense? And what we're actually seeing is the tubes. So we already see the primary, the tertiary, the secondary, the tertiary, the bronchiole, the respiratory bronchiole, the duct, and finally we're at this area right here. So when we get to this, That's what we're seeing. Okay, does that make sense? And this is where air exchange happened, and you can see that there's arteries and veins all around it. Cool? All right. Okay, so that is respiratory. Now let's look at digestion. All right, so this is, I don't care about that. Go away. Okay, so we started with the teeth. All right, what's the overall picture for digestion? Yeah, we want to break down macromolecules to micromolecules. Okay, so this is going to start with the teeth. Okay, because you got to tear things up. Any of you ever swallowed an apple whole?
No.
I didn't think so. Okay, so you have to break it down. Okay, so we have a anatomical crown and then a clinical crown. A clinical crown.
Clinical.
I do jokes like this on myself, so you can feel free to join in my jokes and stuff like that. Okay, so what I see is what you brush is your clinical crown. What you floss to is your anatomical crown. Okay, because you have to get that floss underneath the gum. Okay, then we have going outside in. We have the periodontal ligament. Then we have the cementum, which is this little mustard yellow right here. It's 23, and then you keep going in till you get that dark yellow. That's the dentin, and then you take all this stuff out. That's the pulp cavity. Okay, so the pulp contains the blood vessels and stuff like this. So there's really no cavity in there per se. It's still got this vessels and stuff in there, but that's how that works. Okay, and then the dentition. We have 2 incisors. Two incisors. Okay, so these first 2 are your incisors. Then you have your canine, okay, which is your vampire teeth. And then you have your premolars and then your molars. And like I said, if you're incredibly smart, you probably got some wisdom teeth coming in there, right? All right. We looked at the tongue. And we notice there's 2 sets of muscles on the tongue that we need to be concerned with. The first are the extrinsic. So what does extrinsic mean? What does it mean? Out of the tongue. It's not in the tongue itself. It's out of the tongue. And we have 3 that I wanted you to know that move the tongue. Oh, I guess I didn't want you to know it. I just want you to know who they are. Okay. So here's genioglossus, hyoglossus, and styloglossus. Cool. And if you look on the change these notes, you guys should know this stuff. There's no reason why you don't have to know that. Okay. And then we have the intrinsic within the tongue itself. Okay. So we have longitudinal and we have what do we call it? Like the radial. Cool. Salivary glands. How many do we have? How many? 3, of course. If you've got more than 3, I want you to tell me where they are. Okay. Ow! Ow! God, my neck hurts. All right. So we have the parotid gland. We have the submandibular. Also over here, we can see the submandibular. Now, see, you know what this bone is? Yes, this is the mandible, and we have a gland underneath the mandible. Well, sub means underneath, like submarine. Okay, submandibular, and then we have this one right here. That is a tongue, so this is sublingual. Can't get any easier than that, right? I like this guy. He's good. All right. Then we're looking at the esophagus, or if you pronounce it correctly, the esophagus. And I like this model here. In fact, this is the best model, I think, for that one. Okay, so from here, and remember, there's the epiglottis. So here's the traveling for airway. This is going to flip down and going to shunt the food to the tube behind it. So upper esophageal sphincter, lower esophageal sphincter, and then we said that about here, halfway, it changes from voluntary muscle to smooth muscle. Okay, which means it is subject to peristalsis. Okay, so once it gets here, it just pulls it through. Then we get into the stomach. The stomach, this area here is the cardia. Then we have the fundus, the body. Here's the pyloric antrum, the pyloric canal, then the pyloric sphincter. And then we said the folds in the stomach themselves are called rugae. Groovy? All right. Then we looked at the muscles. Why do we have muscles in the stomach? Why do we have so many? Yeah, because we need mechanical digestion. We need some way of moving this stuff that's in the contents in the stomach into the duodenum so that it can go through the rest of the body. Okay, so we have longitudinal coming this way. We have circular coming like this, and then you see the cutaway right here, and you see an oblique. You see an angle. Okay, so that is the oblique. Let me move this thing. Stomach sits about right here. Obviously, you can see there's a lesser curvature and a greater curvature. And then on each curvature, we have omentum. Okay, so the lesser omentum is here. It usually goes up to the gallbladder and proximal parts. This goes down. It also makes like a fat pad covering the visceral organs. All right. Pancreas. All right, this one's always fun. Okay, so this is the pancreas. This is the pancreas, and then our big model over here also has a pancreas. And all three have different information that is kind of. I wish they were all on the same model. Okay, so the head, and remember, the head is in the crook of the duodenum. Okay, the body's extending, and then the tail pierces the spleen. Does that make sense? Okay, so it's like I got your liver, but it's not. I got your spleen. Okay, then we're looking at the pancreatic ducts. So you see the white ductwork that's inside there, and you see the sort of dull gray-green coming through there. Okay, so that's the pancreatic duct. Okay, then this the hepatic pancreatic ampulla is where this one doesn't have a good one. Is where the bile duct coming from the gallbladder fuses with the duct of the pancreas, okay, the pancreatic duct. So that's the ampulla. And then as you pop into the duodenum, you have a sphincter of the hepatopancreatic ampulla. It's also known as the sphincter of Oddi, and it's got a little papillae. Papilla just means like a little nipple, okay? So if you're ever dissecting a human and you're looking for that thing, or even a cat, you just run it there, it feels like a little pimple. Okay, and so that's what that is, okay? So there it is. So if I point that and say name this sphincter, or name this protrusion, okay? And then we have another one coming out there. This is the accessory duct, okay? So don't you like to accessorize? Well, so does the pancreas. Okay, so you can see it here too. There's the pancreatic duct. There's the bile duct coming down. You see it fused. You see the papilla. And in that papilla, you have to know there's a little sphincter. So name that sphincter, name the protrusion, okay? So that's how that would be named. All right. I'm sure you've heard this one in your life. I cut your liver. Okay, because now you never heard that? I'm not really going to do it. Were you afraid that I was really going to cut your liver? Say, it's just a joke. Okay. But you know, you want to touch my liver?
Gross.
Touching my liver. Okay, so you can see we got a variety, but they all have the same shape. Okay, remember, these are all presented like backwards and stuff like this, but this actually does like this, so they fit like this. So the right side is the huge side, then the narrow side pointing to the other side is the left side, okay? And then we have, so that's easy to see, okay? So this is right, this is left. This, since they think it looks like a little tail, well, let's see, we've got the quadrate. Quadrate here is the square-shaped one, okay? But what's your clue? What's your real clue that that's the quadrate? It's next to the gallbladder. Okay, so you see gallbladder, you think quadrate, not caudate, not with a C, with a Q. Okay, now you get up here by this inferior vena cava, and there's your caudate. Okay, and remember, caudate means tail, so they thought that looked like a little tail. I thought they're stretching it kind of did, but you know, what can I say? We didn't talk about ligaments, did we?
No.
Okay, so this one has a nice white one. Okay, so the coronaries are right up here. There's where the this is where the diaphragm is going to attach, basically. The half over here, and then this is the round ligament. Okay, and then this one back here coming down is called the falciform. Cool. So let's look at these. Okay, so this is the falciform here, coming here. This is the round ligament. And then these coming up here on top are your the coronary ligaments. So it fits in like that. Ruby? All right, so this one gets kind of tricky. This seems to be our best model here. Okay, so if you're coming from the right and the left, and remember they're the green. So right, left hepatic duct, coming from the right side, coming from the left side. The common hepatic duct are the ones that are going like in to the gallbladder. And then you actually have to go out through that. And then the one that's going down that merges with the pancreatic duct, that is the common bile duct. So if you're going to the hepatic, the common, then you have the cystic duct. Cystic duct goes to the gallbladder, sorry. So when these two merge, they become the common hepatic ducts. They go to the cystic duct. Then when you need bile, you go back to the cystic duct and then you go down to the pancreas and the duodenum via the common hepatic duct. The common bile duct. Whew. Can't say these things. Must be the Alzheimer's. Not the Alzheimer's. What is it? Confusion? The other class thinks I'm going to be 93 my next birthday. You guys know I'm going to be 94. Okay. All right. So, small intestines. Where's my good model? Oh. Can you believe it? I left it over here. Has anyone ever said I cut your small intestine? No. Okay, that's not really one they say a lot. Okay, so when we look at this, there's the stomach, okay? Then you go through this little small area. Duodenum means two feet or something, 2 fingers, something like that, okay? So you come here, and we just wrap around, and it's just what you see here, right here. Okay, we can see very pretty, really very pretty in there. The plicae circularis. okay? The plicae circularis. And then here's the jejunum, here's the ileum, and when we get to the end of the ileum, then we have the cecum, right? This is the appendix. Then we have the right ascending colon with the right colic flexure, or I think in your lecture it was called, what was it called? What do they call it? Right hepatic? Yeah, hepatic. Then we have the transverse, and then you have the left flexure, and what do you call it, splenic? Yeah. Then we have the descending, and then let's see if I can find a better one. Who's over there? You're not very good. Let me see if you're good. No, you're not good either. You don't even have it. Nope. Oh, here we go. You're the good one here. All right, so here we have the cecum. We have the ascending, the flexure, the transverse, the left flexure, the descending. Here is your sigmoid coming this way. Okay, until it gets to here. When it goes straight again, it becomes the rectum. And then as you go out, it becomes the anus. Cool. And then you have your sphincters. And we have an internal sphincter that's in involuntary control, and then we have an external sphincter that's under voluntary control. And that's a good thing. On there, we have the tape of the colon. This tape of the colon is called the tinea coli, and all the little pockets there are called haustra. Okay? And you know that you fill one haustra, then you have peristalsis, and you go to the next, and then you go to the next one, and you go to the next one, and you go, until you get to towards the end. But you can have a mass peristalsis starting about here, and it just drives the contents of the large intestines towards the anus. You better go find your bathroom. Cool? All right. So now we have histology. And let's see. That's not what I want to see. This you're going to have to get from the slide presentation. And we are looking at this model over here. Let's see, you got one. Who else has one? We only have two? I thought we had three. Oh, you got it. Okay, good. Okay, so this is a catch-all model for all the intestines. Okay, so we are looking at that. So we have and I want you to use the muscle layers as your markers. Okay, so this muscle layer here on up, this is the lumen, so this is all mucosa. Okay, this here from this muscle to these muscles is the submucosa. And then, of course, the muscles is the muscularis externa. And then you come down here below that, and that's the serosum. Okay, so this is basically connective tissue to keep you in place to where you're going. Okay, and remember, this is a small section. It actually goes around like this to make the tube. So we're doing like this to make the tube. Cool? And then the contents is going to flow through here. Okay, and you see that we have artery, vein, The dark green is your lacteal, and then we have the gray is the lamina propria. Okay, so we are not showing smooth muscles in the vessels and stuff like that, but you can see this muscularis mucosa right there. Okay, if you look on the side, you can see the crypts of Lieberkuhn, and you can see the Paneth cells, which I have beautifully drawn over there, and I'm going to pick it up tonight so that these other people, I'm glad people appreciate art, but I don't know why they're taking our artwork. There's the muscularis, there's the lamina propria, there's the submucosa. Okay, so in the submucosa we still have arteries and veins. Okay, you can see the nerve supply coming down in there. In there we have the Meissner's plexus. So this one right here, all this network you see here, name this nerve network. Okay, that's Meissner's plexus. Okay, then we come to the muscularis layer, and there's a habit I want you to get into. Okay, when you see muscularis externa, you always think intercircular outer longitudinal. Okay, if anyone comes up and says muscularis externa, you say, oh, intercircular outer longitudinal, because that's the order that it's always going to be in. Okay, intercircular outer longitudinal. In there, we also have this nerve plexus that you see in here. Can you see that? Can you see it? Does it look good? Okay, so that is my enteric plexus. Okay, and this is the one that communicates with the vagus nerve. Okay, so we have a gut-brain axis, and then a brain-gut axis, and then the gut axis is actually all the hormones. We have paracrine glands that release hormones and work on the nervous system itself. So that's why I say all this is self-sufficient. It's self-sustaining. There's all sorts of stuff that go on and feedbacks to itself to keep it going, depending on what's going on in the intestines, in the GI tract. Okay? And then the serosa is at the very end. Nerve supply, connective tissue. My favorite model. My friend just found out she had SIBO. So this that I talked about, small bowel overgrowth. So she's got put on a very strict diet to keep all the fermentators from doing their thing and causing the hydrogen producers. Hey, what happened to my slides? Here we go. All right, so we're doing the esophagus. The esophagus is the first slide we have over there. And if you just flip this way, we can see everything we have here. Okay, so there's your epithelium. This is in the esophagus. So remember, first part of it is, it's lined with non-keratinized, stratified squamous epithelium. Right, because you have to have tissue that can lose a lot of cells in there. Because even though you chewed that apple up or you chewed that hard candy up, it can still scrape off stuff. So you need something that can lose it without affecting it. Okay, and then we have intercircular outer longitudinal. Here's our glands that we have. So those submucosal glands to produce some mucus and stuff like that to help that come down. Okay, so pretty much our slide looks like that. And then our stomach cells, actually we're not looking so much at all this stuff. Now we do have mucous neck cells on this thing, but we're actually going deep and looking at these. Okay, and the section I have, I think we have 2 of these big cells. So what's your clue on this? Big and little. Big and little. If you see big nuclei with a lot of cytoplasm, and then you see, this one is going to be darker than this one. Unfortunately, our slides aren't as pretty as these sections are. They look kind of bland, like all one color. So we go big and little. And the pointer is on, I think, 2 bigs and then 3 littles right over here. Cool? Look at those gastric glands. Okay, so there's what it looks like if we had the colorful ones, but we don't have that. But we do have big and little, so you can see that. Okay. Over here, we do have this. Turn it sideways again. That didn't get changed, did it, from last week? When you looked at that? So. No, it's beautiful. All right, flip it sideways. Put 2 bile ducts over here and 1 of these over here, and you got this picture. Okay, a little bit rearranged. Okay, what's your clue that it's a bile duct?
Oh, this clump
What is-
cells.
Cuboidal epithelium. Cuboidal epithelium. What's your clue that this is an artery? Stratified squamous. What's your clue that's a vein? Huge opening. Okay, so it's big. It's huge compared to the other two. Okay, and what do we call that collectively? Yes, a portal triad. I knew you were going to say that. It was right on the tip of your tongue, wasn't it? All right, so there's the small intestines. We are going to look at the duodenum, and we can see the crypts of Lieberkuhn. Okay, so you can see the villi. You can see how. You can see all this stuff, right? So all this stuff follows suit just like this. Then you turn it here, and there is your crypt, sneaking down into there. These little red cells, which in our slide, and I got a label for you, actually looks like just tiny dots of red. We don't have as pretty, just bright red like I've seen before, okay? And then you can see the Brunner's glands, which are in the submucosa, okay, over there. And it's beautifully labeled. I'm sure if I don't pick it up, someone will steal it, because apparently they like my artwork. I'm not going to show my dinosaur. Let's steal it. Okay, so our slide presentation is sort of like this. If you flip this the other way, you can see this. See how the Panna cells are just sort of red, and then you have the cells that make the wall. That's what we have over there. I've got one up here where the crypt is going down into it, and then you can see the Brunner's gland. Just take this slide here and flip it like this, okay? And that's the section. I've tried to get something that looks as close to this as possible. And then we go to the Peyer's patch. Man, I'm telling you, ours is similar to this, but huger. Is that like the big coffee? What's the name for the big coffee at the Starbucks? What is it?
Venti.
Venti?
Mm-hmm.
Is it Italian?
Yeah.
Well, ours are venti, okay? I mean, they're venti. They're big like this, but you can see this, and you can see this down there. So even though they're venti, you can still see the rest of the stuff. Cool? This Starbucks, Grande is chiquito and venti is Italian. And who knows if it's even accurate? What do you notice about the colon? Goblet cells. So that's what you're going to look for. Okay? So that's it. I had a little neighbor boy all full. You know how you can hit your car and it'll beep?
Mm-hmm.
So I went, beep. He's like,
Scared him.
all right, so that is it, okay? That is it. So there's the slides.